Okay, good morning, all of you. So we have seen all three types of characteristics which we can draw for SCR. In earlier few sessions, we have seen those characteristics. We know that there are three characteristics, different characteristics, like switching, DI, and decay characteristics. So these three characteristics are important. Whenever SCR is considered, these three characteristics will be helpful to select SCR power rating and to choose a proper SCR for given application, because we know that SCRs are used in different power electronic converters. So based on the rating of power electronic converters and the load which we are going to connect to the converter and the kind of application we are using, so we need to specify the rating, power ratings, voltage current ratings. On that basis, those characteristics will be helpful. Again, those characteristics are also important to understand the concept and the understanding of the working principle of SCR. Okay. So apart from that, there is one more concept in SCR. We know the SCR is composed of semiconducting material like silicon. We have learned the structure of SCR, where the alternately placed P layer and N layer. There are four layers, one above the other, and we have four terminals. Anode to the P side, cathode to the opposite N side, and gate closer to the cathode. This is what is general arrangement of the structure, or the simple structure of SCR. But there is one more angle to look towards SCR. You can assume SCR as if there are two transistors which are connected back to back, and that concept is known as two transistor model of SCR. So SCR can be seen as a two transistors, that is BJTs. Two BJTs, they are connected back to back. That is inbuilt. There are two transistors available, but in all, there is only one SCR. How can we get that? As we have discussed that the SCR structure has four layers of P and N material alternately placed. If we bisect that structure which is available with us in this way, from the second layer of N material to the second layer of P material. In this way, if we could bisect the structure of SCR, and if we could isolate them, then form the structure like this. Now, if I say the first P layer, the top P layer, which is where the anode is connected, is not bisected. At the opposite side, the N layer is also kept as it is. But the two layers which are placed in between them, P and N, they are bisected. And they are kept apart. They are made apart. Based on that, we could get two different structures. In one structure, we will have P and P, and in another structure, we will have NPN. So, what do you mean by P and P? It is transistor. So, we have the first type of transistor, PNP, the another type of transistor, NPN. And how they are connected? They are connected like back to back. Okay. Now, if we convert this structure, into the circuit, that is equivalent circuit of this structure, it will look like this. And you can easily conclude that there are two transistors which are connected back to back. Okay, so if I say this is transistor PA and this is transistor PB, these two transistors are connected back to back. The earlier transistor is PNP type, the later transistor is NPN type. But the thing is that they are connected back to back. Here you can show the gate terminal, here also that gate terminal is available. So the gate is common with PNP as well as NPN. Now if we mark the current direction according to the conventional currents in PNP and NPN transistor, then it will be like this. These are the currents. So this current we call generally. Now if we see, this is actually what? SCR. So this current from anode to cathode, we call it as a anode current. Okay, but if we look at the transistor, this current looks like as if it is emitter current, because in transistor we know that there are emitter, base and collector. So here P is emitter, N is base, and again P is collector. If we assume so, we can say that the anode current of the device is equivalent to the emitter current of the first transistor. So IA is equals to IE1. Now, the next current important is, here if I assume the output current of the second transistor is again emitter. Okay, so the cathode current IK is equal to the emitter current of the second transistor, because this is NPN transistor. So IA is equals to IE1 and IK is equals to. Okay, now this particular current is base current. So you can call this is base current of first transistor is equals to this is collector current for the second transistor. So IB1 is equals to IC2. Why? Because base and collector, they are connected together. Okay, in two transistor model, the base of first transistor and the collector of the second transistor, they are connected together. That's why I can write base current of first transistor is equals to the collector current of the second transistor. Initially I have written anode current is equals to emitter current of the first transistor and cathode current is equals to emitter current of the second transistor. Okay, now here this current is current IG. Okay, here you can write IG is equals to IGT, because base current of second, and this one is IC1, because this is collector. So we have emitter, base, collector in the first transistor, collector, base, emitter in the second transistor, and we can put equivalence between these currents. So how we get this? The first expression, which is very important, is anode current is equals to emitter current of the first transistor. The second expression, important expression, is this: the cathode current is equals to emitter current of the second transistor. And rest of the, you can put equivalence, but those they are not important, because we are looking forward for how the transistor will contribute to the working of the device, working of this SCR. How this transistor contributes to the forward current of the device. Now the forward current is actually anode current, which flows from anode to cathode. So in this traveling of that current, how these two transistors are contributing, or what is the correlation between the two transistors and the working current of the device. Now working current of the device or forward current of the device is anode to cathode current. You can also write it as an anode current. So we want this current. How this current depends upon the working of these two transistors, PA and PB. Okay, just like we characterize the working or the principle of the SCR for forward current, because we require forward current to flow from the device. So that is how we place the device in the working. Okay. So that is the important parameter for SCR. Okay. Now, can anybody tell me? This is very tricky question. Can anybody tell me among yourself that which parameter is important for transistor? If I say the anode current of SCR is contributed by the two transistors, it will contribute in terms of what? Is there any parameter associated with the transistor which will control this current? Or is there any relation between the anode current and the parameter of the transistor? So what is that parameter? What should be? For transistor, which parameter is important? Can anybody tell me? Because if you could understand this, then it will be clear that you know the concept. And transistor, obviously, you have learned this. You are learning analog electronics in the first year, in the second year, and in the first year also in fundamentals of electronics engineering. You have learned the transistor, and previously also you know what is transistor and which parameter controls the transistor. We need to show the correlation of anode current to the parameter of that parameter of the transistor, which will actually control the current. And hence we can conclude that SCR has two transistor analogy or two transistor model. That is, SCR behaves as if there are two transistors. Okay. So what is that? Which parameter? Can anybody? And for that only we are discussing this point. म्हणजे आपल्याला शेवटी असं काहीतरी पाहिजे की ज्याच्यावरून आपण म्हणू शकतो की बाबा ट्रान्झिस्टर हा जर आपण एनालॉगस पकडला, एससीआर हा दोन ट्रान्झिस्टरला एनालॉग पकडला तर त्याला प्रूफ काय आहे? व्हॉट इज एव्हिडन्स फॉर दॅट? कशावरून आपण हे कन्क्लुजन देऊ शकतो? जर आपल्याला डिव्हाइस साठी एससीआर साठी महत्त्वाचा कुठला करंट आहे? एनोड करंट. याचं रिलेशन ट्रान्झिस्टरच्या एका पॅरामीटर बरोबर आपण लावू शकतो कुठल्याही, तर आपण असं म्हणू शकतो की there is a two transistor model available in SCR. So what that parameter is? Now emitter current is there, collector current is there, base current is also there. Apart from these currents, because you know BJT is current control device. So what is important in BJT is current. What is important in SCR is also current. But apart from these three currents, these currents are not that important for anode current. But what is important? Can anybody tell me? Because this is something very important and something very basic, fundamental that you have learned. I won't say that you have not learned. I won't accept because you have learned that. हे तुम्ही शिकलेलं आहे हे मला माहिती आहे आणि म्हणून हे तुम्हाला विचारतो. ॲज अ टोल जे तुम्ही शिकलेलं आहे ते तुम्हाला मी विचारणार नाही. That single term is important. What is that? Anybody? Only 62 are joined. In 60, it is poor attendance today. including meat is 60. So that's all. Yes. Anybody?
करण लेफ्ट हो. सर आहेत की नाही.
अथर्व सरांना कॉन्टॅक्ट कर की.
लेफ्ट झालं का मी? ओके, वेट 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 वेट.
हॅलो सर.
मध्ये असल्यास मला समजत नाही, लवकर कॉल करायला पाहिजे होता. ओके ठीक है एटलीस्ट ओके I don't know how I was left, but due to the technical glitches of the network problem, I was left. And I was not knowing that I have left the meeting. Really sorry for your time that has gone. And my efforts are also gone because I was in the presentation mode, so I may not be knowing I was left. So I hope now it is fine. Okay with the presentation. It is almost 25 minutes I was left. So this is the derivation how anode current correlates with the current gain. So current gain is the important parameter in transistor. That was the answer I was expecting from you. So we need to put relation between anode current and current gain of both the transistors. So how it can be derived? Let's see. Okay, for transistor you can write the collector current is equals to beta into IB, where beta is the common emitter forward current gain and alpha is a common base forward current gain. For the first transistor, you can write IC1 is equals to alpha 1 plus IA plus ICBO1. What is ICBO1? The leakage current, forward leakage current. What is IA? The anode current. What is alpha 1? The forward current gain. Okay, common base forward current gain. Similarly, for transistor 2, IC2 is equals to alpha 2 plus IK plus ICBO2. Okay, so we have got the both the collector currents. Now these both the collector currents will contribute to anode current. By applying KCL, you can write anode current is the summation of collector current of both the transistors. That is IC1 plus IC2, IA. I want relation of IA with the current gain. Okay. Now I can write expression for IC1 and expression for IC2 in that equation. So IA is equals to alpha 1 plus IA plus ICBO1. This is IC1. Okay. Plus alpha 2 into IK plus ICBO2. This is IC2. Now rearranging the terms by eliminating cathode current, because I don't want IK, I want IA. So IK is equals to IA plus IG. So you can replace IK by IA plus IG in the next expression. So you will get this. IA is equals to alpha 1 plus IA plus ICBO1 plus alpha 2 Instead of Ik, I will write Ia plus Ig plus ICBO2. And rearranging the term, Ia to the left side only. So Ia is equals to alpha 2 Ig plus ICBO1 plus ICBO2 divided by 1 minus alpha 1 plus alpha 2. Now from that expression, I can conclude that if I go on increasing the current gain, that is summation of alpha 1 and alpha 2 for the transistor, the anode current can be increased. That is, as alpha 1 and alpha 2 are increased towards unity, the anode current will result in increased. Okay, anode current will increase. This is how the anode current depends upon the current gains of two transistors. And from that, what you can conclude? You can conclude like SCR can be seen as a two transistor, they are connected back to back, or SCR follows TTM model. Okay, what is the proof for that? This expression, the relation between current gain and anode current. Alpha 1 and alpha 2 are important for transistor current gains. आतापर्यंत आपण गेट थ्रू SCR ला ऑन केलं होतं. त्याच्याशिवाय काही मेथड्स आहेत की ज्याच्यामध्ये आपण गेटला SCR ला ऑन करू शकतो गेट सोडून. व्होल्टेज ट्रिगरिंग आहे, थर्मल ट्रिगरिंग, लाईट ट्रिगरिंग, dV/dt ट्रिगरिंग अँड गेट ट्रिगरिंग. ट्रिगरिंग कशाला म्हणायचं? SCR कॅन बी टर्न ऑन. द प्रोसेस ऑफ मेकिंग टर्न ऑन दी SCR इज कॉल्ड एज ट्रिगरिंग. आपण 5 पद्धतीने 5 मेथडनी SCR ला टर्न ऑन करू शकतो. Then ask explain triggering methods for SCR. So these are the methods. There is a list of 5. Okay, voltage triggering, thermal triggering, light, dV/dt and gate triggering. आतापर्यंत जे आपण बघितलं गेट टर्मिनल जिथं जिथं आलंय ते गेट ट्रिगरिंग आहे. And this is the sophisticated method to turn on the SCR, by which you can at least control the turn on process for SCR. Okay, so these are the triggering methods, and triggering methods are associated when SCR is turned on. Now what is voltage triggering? Here the applied voltage is gradually increased beyond the value known as forward breaker voltage VBO, and gate is kept open. So there is no role for gate. This method is not preferred because during turn on of SCR it is associated with the large voltage and large current, which results in huge power loss in the device and it may damage. Okay, so voltage triggering, the device is connected in the forward bias and the forward voltage is increased beyond the breaker voltage. So after breaker voltage, what happens? Junction J2 breaks down and there is avalanche breakdown. Because of junction J2 is breakdown, junction J1 and J3 will also break down after some time. That is called as avalanche breakdown, which will increase the heat loss in that device, which will damage the device. So this method is not adopted. This method is not preferred. Okay, voltage triggering. Thermal triggering. If the temperature of SCR is high, it results in increase in the electron hole pairs, which in turn increases the leakage current alpha 1 and alpha 2 to rise. Okay, so current gain will increase. So internally two transistor model will play vital role in thermal triggering, which will be having current gain. So if there is an increase in the temperature, increasing the electron pairs, hole pairs, which will increase the current gain. The regenerative action tends to increase alpha 1 plus alpha 2 to unity and SCR may be turned on. So this is the method by which SCR may be turned on. So alpha 1 and alpha 2, their sum will be important. This type of turn on is not preferred as it may result in a thermal runaway. So earlier there was a avalanche breakdown, now it is thermal runaway. Okay, these two concepts. Earlier there was voltage breakdown, sorry, the junction breakdown. Okay, or the above breaker voltage junction breaks, and because of which there is a breakdown, damage of the device. Here there is a thermal runaway, and hence it is avoided. This method is also not adopted. Light triggering, the rays of light, the rays of light are allowed to strike the junction of the SCR. एका ठराविक टाईपची लाईट जी आहे ती जंक्शनच्या डिव्हाइसच्या जंक्शन वरती काय केली जाते, स्ट्राइक केली जाते, and it results in increase in the number of electron hole pairs. जसं जसं थर्मल ट्रिगरिंग आहे तसं लाईट ट्रिगरिंग मध्ये पण काय वाढतात, इलेक्ट्रॉन होल पेअर्स वाढतात आणि एससीआर मे बी टर्न ऑन. The light activated SCRs like laser, you must have seen laser, we say laser beam. Okay, the light activated SCRs laser are triggered by using this method. या method ni turn on केली. Okay, dV by dt, if the rate of rise of anode to cathode voltage is high, the changing current through the capacitive junction is high enough to turn on the SCR. Okay, so here the rate at which the voltage increases, the rate at which the voltage is changed, okay, the voltage is high, the changing current through the capacitive junction is high enough to turn on the SCR. Okay, because we know that voltage and current, they are associated with it. So the rate at which we are changing the voltage can be increased, so it will increase the rate of capacitive current also, and due to which the SCR may be turned on. A high value of changing current may destroy the SCR, hence this device must be protected against high dV by dt. Means what? This method is also absolute. It is not used that much because it will damage the device also. And the last method is gate triggering method. जे आपल्याला एक्सपेक्टेड आहे ते पाचवी मेथड, गेट थ्रू एससीआर ला ऑन करायचं. दिस इज सॉफिस्टिकेटेड मेथड. म्हणजे ज्या अगोदरच्या मेथड्स आपण शिकले, डीव्ही बाय डीटी असेल, लाईट ट्रिगरिंग असेल, किंवा थर्मल ट्रिगरिंग असेल, किंवा फॉरवर्ड व्होल्टेज ट्रिगरिंग मेथड असेल, किंवा व्होल्टेज ट्रिगरिंग मेथड, तर या मेथड अडॉप्ट एससीआर ऑन होऊ शकतो, इवन लाईट किंवा थर्मल ट्रिगरिंग पॉसिबल आहे, परंतु व्होल्टेज फॉरवर्ड व्होल्टेज ट्रिगरिंग असेल किंवा डीव्ही बाय डीटी ट्रिगरिंग असेल, या ज्या मेथड्स आहेत त्या डिव्हाइसला डॅमेज करू शकतात, त्यामुळे जास्त यूज केल्या जात नाही. एससीआर कॅन बी टर्न using one of the following technique through gate: DC triggering, pulse triggering, and high frequency carrier. Okay, so this method of SCR triggering is widely employed because of ease of gate control over the SCR. कारण आपण इझिली SCR ला टर्न ऑन करू शकतो गेटचा यूज करून, आणि तेच त्याचं पर्पज आहे. जर टर्मिनल अवेलेबल असेल तर टर्न ऑन करण्यासाठी, तर आपण तो काय यूज करायचा नाही, आपण करू शकतो. आणि इफिशियंट मेथड आहे ती टर्न ऑन करायची, की ज्याच्यामध्ये आपल्याला कंट्रोल्ड टर्न ऑन मिळतंय, शिवाय डॅमेज होत नाही डिव्हाइस, आणि त्याचं प्रोग्रामिंग पॉसिबल आहे. Once the SCR starts conducting, the gate loses its control over the device and SCR continues to conduct. This statement is repeating regularly because gate has only role to play during turn on. Once it is turned on, it will lose the control. You can remove the gate pulse. Okay? SCR can be turned by using the following techniques through gate. आता मग गेट थ्रू टर्न ऑन करायचे असतील तर कुठल्या मेथड्स आहेत का, म्हणजे गेटच वापरायचा आहे, परंतु कुठल्या वेगवेगळ्या पद्धतीने तो आपण वापरू शकतो. डीसी ट्रिगरिंग, पल्स ट्रिगरिंग अँड हाय फ्रिक्वेन्सी ट्रिगरिंग, हाय फ्रिक्वेन्सी कॅरियर, या मेथडने आपण काय करू शकतो, डिव्हाइसला टर्न ऑन करू शकतो. सो दे विल आस्क लाईक एक्सप्लेन ट्रिगरिंग मेथड्स ऑफ एससीआर, विच आर दोज: forward voltage triggering, thermal triggering, light triggering, dV by dt triggering, and in the end gate triggering, and which is preferred, gate triggering. Okay, so that's all for today. 401, 401,